So folks, now we want to look at the topic of solving some basic trigonometric equations. This that I outlined in the previous video, this pre-work, I think is an essential skill. You cannot be successful in the second part unless you understand the basics of question number 4 here. So please make sure that you've watched that pre-work video first. All right, so let's go ahead and take a look at this problem right here. We're asked to solve, and I'm sorry these numbers are a little in the way, 2 sine of theta plus 3 square root of 3 is equal to 2 square root of 3 on the interval 0 to 2 pi. Notice that's why we reviewed the idea. All of these problems that I'm asking you to solve are on the principal interval. What we will do later on in this course is we will ask for you to solve equations on some other interval, and those will be a little more challenging. But for right now, we're ready to just solve this equation. So the first thing I'm going to do is I'm going to isolate the trig expression. So the first step is you always isolate the trig expression. So, and that holds whenever you have just one trig expression, like these, I'm calling them simple trig equations, when you just have one trig expression. That's the technique. So if I isolate that, I get that the 2 sine of theta, what I'm going to do here, folks, is I know that this may sometimes look a little intimidating, but these are just numbers. I've got 2 square roots of 3, and I'm going to subtract from them 3 square roots of 3. So 2 square root of 3 minus 3 square root of 3. And when I clean that up, we end up with 2 sine of theta is equal to minus the square root of 3. Then to finish solving for sine of theta, I'm going to divide over the number 2. So all of the elementary rules of algebra are applying here because the sine of theta is just a number. All right, so now we've isolated the trig expression. The next thing we're going to do is we're going to build the reference angles backwards. What do I mean by that? What we're going to do is we're going to go ahead and draw our xy coordinate system here, and we want the sine value to be minus the square root of 3 over 2. Well, remember that the sine value corresponds with the y-axis. So let me label my axes here. Here's the x-axis. Here's the y-axis on that unit circle. And so we want the sine value to be minus the square root of 3 over 2. So let me put a little unit circle up here. And these are just rudimentary. And we want the sine value to be minus square root of 3 over 2. Well, where's that? Minus square root of 3 over 2 for the y value would be down here somewhere. And in fact, minus square root of 3 over 2 would put me right about here. So on the y-axis, if you were to do a decimal approximation of minus square root of 3 over 2, that would put you right about here. And we're going to go and find out where on the unit circle do I have points whose coordinates are something minus the square root of 3 over 2, and something minus the square root of 3 over 2. And in this case, there are 2 points. There's this particular point right here, and from that you could have constructed its reference triangle, etc. And then there's this point right here on the unit circle with this reference triangle that would have, we would go back a half and then down the square root of 3 over 2, and this would be out a half and then down the square root of 3 over 2. So all we need to do now is identify what are these angles, and these are what angles are these? Well, for the principal angles on 0 to 2 pi, there's this angle right here, which takes me to here, and so that would be the angle 4 pi over 3, and then there's this angle here, and that would be the angle 5 pi over 3. Okay, so what I'd like you to try to do here in number 6 is I'd like you to try to do the same thing. This is going to be very similar to the previous problem as far as all the mechanics go, except we're working with cosine of theta. And the hard part is that at some point you'll have this cosine of theta equals a number. And then what you're going to do is you're going to go out to whatever that distance is on the x-axis, and then you're going to find the 2 ordered pairs on the unit circle for that. So go ahead and give that a shot, and I'll help you out in just a moment. So pause the video, give it a shot. So hopefully what you did when you tried this was you went to isolate the trig expression. So this would give me 8 cosine of theta would be equal to 4 square root of 3. Dividing both sides by 8 gives me that the cosine of theta is equal to 4 square root of 3 over 8, which is the same thing as the cosine of theta is equal to the square root of 3 over 2. Okay. So then the next trick is I'm going to draw myself a unit circle, and I'm going to say, okay, I need to figure out where the cosine of theta value is the square root of 3 over 2. So if I were to put a circle on this, I want to figure out where the cosine value is the square root of 3 over 2. Well, help me out, folks. On the unit circle, the cosine has to do with which coordinate, the x-coordinate or the y-coordinate? And the answer is the x-coordinate. So if I were to go out to the square root of 3 over 2, that's maybe right about here. And then if I were to look at where that hits the unit circle, that would be here. And that's kind of, it's not a, this process isn't quite perfect, folks, because it's up to your ability to be able to draw a good circle, and I'm not the best at that, but maybe there we have that, and so that's this point right here. So then if I were to draw the reference triangles for each one of these, there's the reference triangle for the first one, and there's the reference triangle for the second one, and you don't have to label the full order pairs, but notice that this would be the square root of 3 over 2, comma 1/2, and this would be the square root of 3 over 2, comma minus 1/2. And what we're going to do is we're going to just ask ourselves what principal angles give us these values. Well, this principal angle right here, that's the angle theta equals pi over 6. The other one is if I were to go all the way around until I got to here in that principal angle direction. So we're opening up clockwise, excuse me, we're opening up counterclockwise, and we arrive here. What angle is that? That's the angle 11 pi over 6. So when I ask you to solve, when is the cosine of theta equal to the square root of 3 over 2? Those are the two solutions to that problem. Okay, let's keep going. So here in number 7, we're asked to find 5 plus 4 cosine gamma is equal to 7. So let's see here. This would be 5 plus 4 cosine gamma. I'm just recopying it. It's equal to 7. So 4 cosine gamma is equal to 2. Or that the cosine of gamma is equal to 2/4, which is the same thing as the cosine of gamma is equal to 1/2. So what are we going to do? We're going to go ahead and draw ourselves a very rough unit circle. We're not worried about getting this perfect. And then we're going to... Nice to be appreciated. That was weird. Okay, Siri, thanks a lot. So we've got the cosine of gamma is equal to 1/2. And we want to figure out where do I have those coordinates of 1/2 on the unit circle. And there are two places on the unit circle where we have these coordinates of 1/2. They're at 1/2, comma, minus the square root of 3 over 2, and at 1/2, comma, the square root of 3 over 2. It's at these two angles right here. So what are these two angles? The first angle on the interval from 0 to 2 pi would be at pi over 3. And the next principal angle, which means we've got to go between 0 and 2 pi, would be at, this would be the angle 5 pi over 3. Now careful here though, folks. I didn't ask you to do this on 0 to 2 pi, so that's the same thing as 60 degrees. And this is the same thing as 240 degrees. And so our two answers to this problem are gamma is equal to 60 degrees and gamma is equal to 240 degrees. So what I'd like you to do is go ahead and pause the video and try number 8. I'm not going to give you the answer at the end of this video to number 8, so go ahead and just try it on your own and then let me know if you have any questions. Okay, so we have just a couple more remaining. Let's look at number 9 here. So on question number 9, we have 8 minus 7 cosine theta needs to equal 15. And we want to find all the values that we could plug in for the cosine of theta, or for theta there, that would make that true. Well, if I go to solve this, isolating the trig expression, if I subtract 8 over, that would give me 7. So I want the cosine of theta to equal minus 1. So in this case, we're going to give ourselves, if you want, a rough unit circle. But where do we want to be? Well, we want our what coordinate? If this is cosine, we correspond that with x. So we want our x coordinate to be here at -1. What's our y coordinate there? It's 0. And what angle is that? That is the angle theta is equal to pi. Now, again, folks, there's many angles. Like, for example, theta equals minus pi, or theta equals 3 pi, or theta equals 5 pi. There are infinitely many answers to the question, when is the cosine theta equal to -1? Infinitely many answers. But there's only one answer to this particular problem. When I ask when is cosine of theta equal to -1, only allowing theta values to be between 0 and 2 pi. So let's go ahead and pause or what I'd like you to do is pause the video and then try number 10 on your own, and I'll join you with question 11 in just a moment. So hopefully you paused the video and tried that problem. I'd now like to do number 11 with you. This one's a little bit harder because this is not sine or cosine, it's tangent in this case. So here I've actually already got the trig expression isolated, and we want to know when is the tangent of theta equal to the square root of 3. Okay. So this might be one by the end of this class. You may have this answer memorized for this particular angle. But what I'm going to do is I'm going to show you a trick that I find really helpful for these. All of my unit circle ordered pairs that are not on the axis, so I'm not talking about these pairs here, because all of those look like 1, 0 or 0, 1 or negative 1, 0, right? All the other pairs on my unit circle, if you look at their coordinates, let's go back up to where we wrote out that first quadrant of the unit circle. All of the coordinates are divided by 2, and that's going to be really, really helpful here. So when I see that I'm asked to solve the tangent of theta is equal to the square root of 3, if this is going to have nice solutions, meaning unit circle values, then it needs to look like this expression we need to have introduced divided by 2's in there. So how could I do that? Well, I'm going to first think about this as the square root of 3 over 1. Then I'm going to write this as the square root of 3 over 1. Then let's go ahead and multiply it by 1/2 divided by 1/2. Why did I do that? Because I want to introduce these divided by 2's. So this gives me the square root of 3 divided by 2, all divided by 1 divided by 2. Now if I think about this in terms of my, careful, it's tangent, so it's the ratio of y over x. This does look like unit circle values. So the trick here, folks, I think, is if you can't quite recall when is the tangent of theta equal to the square root of 3, which we've actually seen a couple times as an answer, when is the tangent of theta equal to the square root of 3, my recommendation is to write it as a fraction and then set that fraction up so that it's fractions divided by fractions with that denominator being 2. So I rewrote this as the square root of 3 over 2 divided by 1 over 2. That's really helpful because then in terms of x and y, I know I'm going to go out 1/2 and go up to the square root of 3. Or I'm going to go, where else could I go? I could go back 1/2 and then down the square root of 3. So these are the two values. Let me go ahead and put my unit circle on here. These are the two ordered pairs right here. This one, which is the ordered pair 1/2 comma square root of 3 over 2. If you were to simplify that down, it would simplify to the square root of 3. And you also have this one. That one's a little tricky. We see that because that's minus 1/2 comma minus the square root of 3 over 2. Notice that gives me the same ratio. If I say what's the tangent of this angle right here, it would be the y coordinate over the x coordinate. The minus signs would cancel, and I'd be left with this same ratio here, which is the same thing as this number right here. So that's a little bit tricky, folks. Don't worry if you're feeling a little overwhelmed by that. We're going to get more practice as we go. But the idea is that I needed to make this look like unit circle values, so I divided by 2. Okay, so what angles then, if I want to solve the tangent of theta is equal to the square root of 3, where is that? That happens at theta equals, this is the angle pi over 3 for the first one. That's that angle right here. And the other angle is the angle 4 pi over 3. Notice that the tangent values are the same in the first and third quadrant, and they're both positive. Likewise, the tangent values are the same in the second and fourth quadrant, and they'd both be negative. Okay, so finally, folks, we're going to have you try number 12. So pause the video, and then I'll give you one last message. Okay, folks, I know I said that I was going to leave you to do number 12 on your own, but this is a challenging problem, so I'd like to practice it with you. So hopefully you at least tried it. Let's work it together. So we're asked to solve this equation that the tangent of theta is equal to minus 1 over the square root of 3. And so the trick I talked about in the last problem is I realized that, this needs to look like my y over x, but my y coordinates and x coordinates on the unit circle for anything other than things on the axes have denominators of 1/2. So I'm going to rewrite this as minus 1/2 over the square root of 3 over 2. So now I can go to my unit circle, and this is how I would work this problem. We know that the y-coordinate is either a half or minus a half, depending on where I think of that minus sign as being. So for the y-coordinate, let's think that as minus 1/2. So I'm going to go down a half. And then my x-coordinate, which is how far out I go, it would be the square root of 3 over 2. So let's see here. Let's go out the square root of 3 over 2 and then down a half. That would arrive me right here at the coordinates square root of 3 over 2, comma, minus 1/2. That's one location. The thing is remember that when I give you a fraction, if we have minus a over b, I can think of that as minus a over b, or I can think of that as a over minus b. So here we went ahead and paired the negative sign with the y-coordinate, but we could also pair the negative sign with the x-coordinate, so we could go back to the left minus the square root of 3 over 2. We go minus square root of 3 over 2 to the left of that amount, and then up a half, and that would be the other point on the unit circle. So there's that unit circle. There's that unit circle, and there are those 2 points on there that we just sketched. So what are those two theta values? Those are the values theta is equal to 5 pi over 6 is one of them, and the other one is 11 pi over 6. Okay, folks, there will be some selected answers to a few of these problems that I've let you try on your own, but hopefully this gives you a good introduction to how we're going to be solving these trigonometric equations. If you're feeling a little overwhelmed by this, don't worry, we're going to get some more practice with these in class. See you there.